My name is Kainton, the Tech Pro, and today we are going to continue with question 16 on our machine learning question and answers. And this is a typical question you might encounter in an interview, in a machine learning interview, data science interview, or a quiz. So the key thing you need to know about this is that it says what clustering algorithm is better, give reasons. So basically they are telling you what is the difference between k-means clustering and hierarchical clustering, or what are the benefits of k-means clustering over hierarchical clustering, or what is the benefit of hierarchical clustering over k-means clustering. So let's try to make a write-up and try to see if we can get a little comparison. So let's start by writing k-means, and let's write hierarchical here. So let's try to outline maybe a few differences between the two, and from there we'll be able to choose what we'll be able to choose. So one of the differences, k-means clustering have a drawback of having to pre-choose k. This restriction does not exist for hierarchical clustering. Okay, so this is a restriction that says initial value of k needs to be chosen. No initial value of k. So in this case, we've outlined one comparison. So in this case, we have k-means clustering has failed in this case. Let's see if we can outline another one. So hierarchical clustering, once a decision is made to combine two clusters, the decision cannot be undone. Decisions cannot be undone. Cannot be undone. Okay. So, but in the case of k-means clustering, you can actually change the centroid once you've done a recalculation and you find out that the clusters need to be adjusted. You can actually adjust the centroid. So, in the case of hierarchical clustering, no clear objective function is minimized. So instead of writing it out and reading it, let me just read it, and I would like to recommend you actually write it out, because the more you write it out, the more you get used to it. So we have no clear objective function is minimized. We have sometimes breaking large clusters could be complex. Also, hierarchical clustering tends to be more sensitive to noise than k-means clustering. However, hierarchical clustering has the benefit of producing a set of clusters that can be visualized. So based on this, we see that k-means clustering is always preferred. Now, in this case, always you need to learn how to write the objective function. So basically, the objective function is given by this formula j. The function that needs to be minimized is equal to, for all the data points from, let's say j is equal to from 1 to j. Okay, let me use n. For all the data points, n is equal to 1 to big N. Then you go through all the k clusters. So you have k is equal to 1 to n. So Rnj. I already explained this. Rnk. So this is Rnk is an indicator variable that counts for 1 if the data set counted here belongs to that cluster, and it's 0 when data set n does not belong to cluster A. So I already explained this, so I'm not going to explain it again. So we now subtract xn minus the centroid for k, so the k centroid, and then we square it. So basically, this is the key objective function. I think this belongs to k. It belongs to k-means clustering. This is for k-means. So this function is called cost function. Cost function. is also called objective function. So this function is a function to be minimized in k-means clustering. So I'm going to stop here, and in the next class, or in the next part, we'll now discuss what is bias in a machine learning model. I'd like to thank you for viewing, and also like to remind you to subscribe to my channel by clicking on the subscribe button below this video.